Okay, this first video is here to help with problem number 1 on the quiz. Please understand I am not doing problem number 1 on the quiz. You are certainly still doing it, but I'm just going to do a few things here to potentially kind of guide you and help you. Number 1, the problem tells you to find the work done by gravity, which tells you that you are finding an individual work. The most common way to find the individual work is to use F times parallel to displacement, or force times displacement cosine theta. These are, of course, the exact same thing. The cosine in this particular case is here to help displacement be parallel to force. So this second equation is what we're more than likely going to be using if you have the force, you have the displacement, and you have the angle. There are other ways to find it, but we'll talk about that in other videos. Now, since it does that, I've got two situations here. I have a person running up a 10-degree hill. I'm going to say they run 200 meters up this hill, okay? And the force diagram, of course, on the person would be force gravity down, force normal up, force of muscles on person that way, and force of friction back. All that being said, I don't need to carry about any of these other forces right now because it didn't ask me anything about them. It just asked me for the work done by gravity, so I'm going to highlight that right here. To use that first equation, I need to go find the force of gravity in my particular problem, which of course is going to be mg, or 70 kilograms times g, or 686 newtons. Now in your problem, I believe you are given pounds of the particular object. So keep in mind, by the way, pounds are another measurement of force. Force of gravity is in pounds. It's just a conversion. So for me, I'm going to take my 686, just to show you this here, divide by 4.45 newtons in 1 pound, and you're going to end up with a 154-pound person that is doing this particular running. For you, you're basically going to do the exact opposite. You're going to take pounds, you're going to convert potentially to newtons, and if necessary for mass, you can get mass with this equation over here. So we have the number we need. We didn't need to go get pounds in this problem, but you're going to need to know that for later. So right over here, force of gravity is equal to 686 newtons. All right, let's talk about these two equations. This one right here is just the displacement that we have labeled in this spot. Okay, what is this one mean right here? Okay, well, that displacement is the displacement in the same direction as the force, or parallel to the force. Since the force is straight down, that would mean that the displacement, if I divide this up into its x and y, what we actually want is this piece right here. This is the displacement parallel to the force. So the whole purpose of this particular section is to just get that right there. So, maybe, okay, my total displacement is, as we already said, 200 newtons. Okay, but this angle, as we've said, must be measured between the force and the displacement. So as this person is running up the hill, we see from the vertical to the horizontal is 90 degrees, and we see that that little angle is 10, which would mean that this is the cosine of 100 degrees, or just 90 plus 10. Calculate all of this in, and you will end with, I should have calculated this ahead of time, 686 times 200 times cosine of 100. You end up with negative 24,000 joules. Not quite that, but I rounded to the couple decimals. Now, let's say instead the person is rolling down the hill like your bowling ball example before. So here I have the exact same person. Let's say they ran up this hill and then later on they weren't paying attention and they started rolling down the hill. Once again, we got force of gravity this way. We're going to go ahead and say in this particular case they're going to roll, I don't know, I'm just making something up right now. That earlier line was 200. We'll say this is 300 newtons, and it is a very steep hill. It's at 60 degrees. Now, I'm going to take this hill, okay, and I'm going to just kind of make the hill by itself. Here's 60 degrees. I'm going to make it into a triangle, okay? Of course, if I know that 60 degrees, since this is the complementary, 90 minus that is 30. I highlight that to once again point out when you use this equation over here, let's go ahead and clear this away. I would need to use 686 newtons, just as before. The force would be I said newtons over here, that's stupid. That should be meters, my apologies. 300 meters, and now the angle. What's the angle? The angle is measured between the force and the displacement. So this is very similar to your lab. Notice that is not 60 degrees. That's the 30 degrees that we saw earlier. So this would be 30 degrees in this particular case. So in this case, I take 686 times 300 times the cosine of 30 degrees, and you would get 180,000 joules. Key things to highlight in this particular one, well, the conversation between mass to force of gravity and force of gravity in newtons to force of gravity in pounds, or vice versa, and how we found the angle going up the hill, that is 90 plus 10, because of the angle, this is what you're trying to get. And over here, how we get the angle when you're rolling down the hill, which is this 30 degrees, that's complementary, or if you will, it's 90 degrees minus 60 degrees in that case to get that 30. Notice in the first example we got negative because gravity is keeping the person from running up the hill, and in the second case we got positive because gravity is certainly helping the person go down the hill. Hopefully that helps number one.